There is an idea floating around physics departments that nobody wants to be the first to say out loud. It's not a fringe theory. It's not pseudoscience. It's the logical endpoint of equations we already trust. And it suggests that everything you see, this room, your hands, the stars, the entire 13.8 billion year history of the universe might be a temporary glitch inside something much, much larger and much emptier. Physicists have a name for it. They call it the Boltzmann Brain problem. And the reason they don't like talking about it is simple. Once you understand it, you can't prove it isn't already happening to you. So let's walk into this carefully, because the road there is built out of real physics, and the destination is something most people would rather not arrive at. Start with a fact you already know. The universe is expanding, galaxies are flying away from each other, and that expansion is accelerating, pushed apart by something physicists call dark energy. Every year, the gap between us and the farthest galaxies grows. Every year, more of the night sky drifts permanently out of reach. Now follow that forward. Not a few billion years, a trillion, a quadrillion, numbers that stop meaning anything to a human brain. Stars burn through their fuel and die. Galaxies cool. Black holes swallow what's left. And then, slowly, even they evaporate, leaking energy into the dark over timescales so long that the age of the current universe rounds to zero by comparison. What's left is nothing. A vast, cold, almost perfectly empty space stretched so thin that the distance between any two particles is larger than the observable universe is right now. The temperature drops to a whisper above absolute zero. There are no stars, there are no planets, there is no structure of any kind, just a flat, dim, eternal silence. This is the heat death of the universe, and physicists are pretty confident it's where we're heading. Now here's where the floor starts to tilt. Quantum mechanics doesn't allow nothing to actually be nothing. Even in the emptiest vacuum imaginable, there are tiny random fluctuations. Particles flicker into existence and vanish again, borrowed from the universe's energy budget and paid back almost instantly. On Earth, in our era, these fluctuations are imperceptible. But give the universe enough time, and almost instantly becomes a loophole big enough to drive a galaxy through. Because if you wait long enough, the fluctuations get bigger. Not because the laws change, but because rare events stop being rare when you have an infinite amount of time to roll the dice. A fluctuation that produces a single hydrogen atom is common. A fluctuation that produces 100 atoms in the same place is rarer. A fluctuation that produces a coffee mug, fully formed, sitting in empty space, is so improbable it might happen once every 10 to the 40th years. But in an eternal universe, 10 to the 40th years is just Tuesday. Keep scaling up. A fluctuation that produces a working human brain, complete with memories, sensations, and the experience of reading these exact words, is unimaginably rare. The probability is something like 1 in 10 to the 10 to the 26th power. That's a number with so many zeros that if you tried to write it out using every atom in the observable universe as a digit, you'd run out of atoms before you finished. But that doesn't matter, because in an eternal, expanding, heat-dead universe, you have infinite time. Which means even that absurd improbability gets cashed in. Eventually, repeatedly, forever. This is what physicists call a Boltzmann brain. Named after Ludwig Boltzmann, the 19th century physicist, who first stumbled into the math, it's the idea that random thermal fluctuations, given enough time, will spontaneously assemble conscious observers out of the void. Floating brains, or whole bodies, or entire fake Earths, complete with fake histories, and fake friends, and fake memories of growing up. All of it stitched together for a single fleeting moment before dissolving back into the cold. And here is the part that physicists really don't like. If the universe lasts long enough, and current cosmology says it will, then the number of these freak observers will eventually outnumber the number of normal observers like you. By a lot. By so much that the ratio isn't even worth writing down. Think about what that means. If you pick a conscious mind at random, somewhere, somewhen, in the entire history of reality, the odds that it formed naturally on a planet, evolved over 4 billion years, grew up with a family, and is now sitting on a couch watching this video, are essentially zero. The odds that it's a Boltzmann brain, a momentary hallucination of self-awareness in the dark, are essentially 1. So, which one are you? You think you remember your childhood, but a Boltzmann brain would also remember a childhood. The memories are part of the fluctuation. You think you're seeing a real screen and hearing a real voice, but a Boltzmann brain would experience exactly the same thing. There is no test you can run, no measurement you can take, no logical exercise you can perform that distinguishes a real you from a freak quantum echo of you that came into existence 3 seconds ago and will vanish in another 3. This isn't a movie plot. It's not a thought experiment some philosopher dreamed up over wine. It is the direct mathematical consequence of 2 ideas. Physicists already accept that quantum fluctuations happen in empty space, and that the universe will exist for a very, very long time. Put those 2 together, and Boltzmann brains aren't optional. They're inevitable. So how do scientists handle it? Mostly by trying very hard to find a reason it can't be true. One school of thought argues the universe won't actually last forever. Maybe dark energy isn't constant. Maybe the vacuum itself is unstable, and somewhere, sometime, a bubble of true vacuum will appear and expand at the speed of light, erasing everything it touches. If that bubble shows up early enough, the universe ends, before it has time to start spawning random brains. Problem solved, sort of. The downside is that you've replaced one terrifying idea with another, where reality is one cosmic accident away from being deleted with no warning. Another approach attacks the math itself. Maybe the way physicists count observers in an infinite universe is just wrong. Maybe infinity breaks the rules of probability in ways we haven't figured out yet, and the comparison between real minds and freak minds is meaningless. This is the polite escape hatch. It doesn't disprove the Boltzmann brain. It just argues that the question is malformed. A lot of cosmologists find this answer unsatisfying because it feels less like a solution and more like covering your ears. A third approach gets stranger. Some physicists argue that if our best cosmological models predict you should be a Boltzmann brain, and you're clearly not, then the models must be wrong. The Boltzmann brain conclusion is treated as a reductio ad absurdum, a logical proof that something in our understanding of the universe is broken. The problem is, nobody can agree on what that something is. The math works, the observations match. The conclusion still terrifies them. If you were standing on the surface of any planet, anywhere, in any era of the universe's life, you'd have no way to know whether you were really there. Your senses would feel real. Your memories would feel continuous. The wind on your face, the weight of your body, the sound of your own breathing. All of it would feel exactly as real as it does to you right now in your living room on a Tuesday night. There is no internal experience that distinguishes a 4 billion year old evolved human from a brain that flickered into existence 8 seconds ago with the false memory of having lived. That's the part scientists don't like to say out loud. Not because it's unscientific, because it's perfectly scientific, and they can't make it go away. The only thing that pushes back against the idea is intuition, a gut feeling that this can't be how reality works, that something so absurd has to be wrong. But intuition is what told humans the Earth was flat and the sun went around it. Intuition has a bad track record against math. Now here's a small mercy. The current state of physics doesn't prove you're a Boltzmann brain. It just says that if certain reasonable assumptions about the universe are true, then most observers in the long run are Boltzmann brains. And we're statistically supposed to be one of them. There are ways out, there are loopholes, there are research papers being written right now trying to slam the door on this conclusion before it eats the rest of cosmology. Some of those papers are clever. A few might even be right. But none of them have closed the door. Not yet. The mathematics that produces this nightmare is the same mathematics that produces black holes and gravitational waves and the cosmic microwave background. We can't keep the parts we like and throw out the parts we don't. The most uncomfortable thing about the Boltzmann brain problem isn't that it might be true, it's that it forces a question physicists usually don't have to answer. What does it mean for a theory to be right if it predicts that the version of you reading these words probably isn't real? Most scientists, when pushed, will admit they don't have a good answer. They'll change the subject. They'll talk about future experiments, about better models, about how the question might dissolve once we understand quantum gravity. They'll smile and move on. But some of them, late at night, in private conversations, will admit that the math keeps pulling them back. That every time they try to argue Boltzmann brains away, the equations push back. That the universe, taken at face value, seems to want to produce far more fake observers than real ones. And our entire experience of being conscious, of being human, of being here, might be a 1 in a trillion accident in a vast empty graveyard of space. Or it might not. The honest answer is that we don't know. And maybe we can't know. You will turn off this screen in a few minutes. You will go on with your night. You will trust, without thinking about it, that the world will still be there tomorrow. That your memories are real. That your existence has weight and continuity. You have to trust that. There's no other way to live. But somewhere in the back of your mind, the question stays. If a brain in the void can imagine a life and never know the difference, what makes yours different? What evidence do you have beyond the experience itself that any of this is what it seems? That's the theory scientists don't want to discuss. Not because it's silly, because it's serious and it's stubborn, and after decades of trying, nobody has been able to make it go away. Thanks for watching, and I'll see you in the next one.